All right, so in this video, we're going to be looking at a review of some common calculator functions in the TI-84 for graphing functions, evaluating functions, and then also using it for solving systems of linear equations. So we're going to start with the example. We have a function x cubed minus 3x plus 4, and we want to graph that. So we're going to go into our y equals screen, which is right up here under the graphing window. And then on the line y equals y1, we're going to type x caret cubed, x caret 3. The caret button is right under the clear button. It's right here. And then minus, using the subtraction key, 3x plus 4. For the variable, you're going to use the variable key, which is right here next to the alpha key. It will put an x in standard mode, in regular function mode. If you switch to parametric mode, it will type a t. If you switch to polar mode, it will type a theta. And if you switch to sequence mode, it will type an n. But most of the time we're in function mode, and so it will just type the x for us. The TI-83 and the TI-84 handle exponents a little differently. In the newer 84, you will tend to get the screen can be sort of fancy print, and so you will need to cursor out of the exponent before typing the next character. So do be a little bit careful with that on your screen, because otherwise you're going to end up with 3 minus 3x plus 4, all of it in your exponent. And once you're sure that you have the equation written in, press graph. Now, if the entire graph is not showing up on the screen, you can explore various zoom options under the zoom key. The zoom is right here in the middle of your calculator. And so if you go into that menu, zoom 2 will zoom in. So it'll use a smaller range of x and y values, so you can zoom into a smaller section of the graph. 3 will zoom out. So typically it will jump out from -10 to 10 to -40 to 40. So it'll go by about a factor of 4 in each direction. Zoom square will use the same scale for x that you already have, but it will adjust the y range so that things look like circles, so that circles look like circles. Instead of right now, the standard zoom window, this is rectangular, right? And so the issue with that is that it will make circles look like they're squished, so like they're more like ellipses. And if you want them to look like circles so that the number of tick marks is a square on the screen instead of a mini rectangle, then that will that'll be a useful setting. It'll make perpendicular lines actually look perpendicular and things like that. Zoom standard will reset to the -10 to 10 range. Zoom trig will tend to use x range from -2 pi to 2 pi. So if you're in polar coordinates, for instance, that can be useful. And then the y range will be -4 to 4. Zoom stat is useful for graphing data in tables. So if you have data in a table and you're creating a like a scatter plot in your stat plot menu, then zoom stat will adjust the window to match the data in the tables that you're graphing. And 0 is the zoom fit button. So if you have x values on your screen for a particular type of function, it will adjust the y values so that all the points evaluated at all the x values on the screen will display on the screen. In our example here, this is on the standard window, and you can see that the graph kind of cuts off after just about 2 or 3 x values, and all of this stuff is not displayed. If you were to hit zoom fit, the last option in the menu, then it will extend the y values so that all of the y values that go way, 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 way down here will fit onto the screen. Now, for a function like this, that could be a problem because these values way out away from the origin could be very large. And so you might get a very large range of Y and hardly be able to see the middle of the graph at all. But if that happens and you use Zoom Fit and you're like, okay, this doesn't help, you can always go back to Zoom Standard, which is Zoom 6, and it will readjust back to the window you started with here. Now, you can also adjust values manually. If you go to the window function, it will give you a list of these options, and then you can fill in these values as it pleases you. Now, to display a table of function values, you would go to second graph. So again, the graph key is the one that is way over on the right of our calculator. And so second graph will take you to the table menu. And then you can scroll through values. The X values will be plugged into your equation, and the Y column will display the values of that are displayed here plugged into the equation that's on your Y1 screen. If you have other equations in Y2 or Y3, they will also display here, and you can scroll left and right in order to get more of them. To specify where your table starts, what values are displayed, and the increment size, go to second window. This will be the table set option, and it will give you options for putting in starting and incremental values. So your screen will look like this in that menu. So here, if you want to start plugging in values at, say, -5, use the negative key, not the subtraction key, before the 5. And the delta table is essentially saying, how quickly do I want to increase those values? So if I put in 0.5, I'll start at -5, and then I'll do -4.5, and then -4, and then -3.5, and then -3, and then -2.5, and then -2, and so forth. It'll go by 1/2. So as you go through the list, it'll increase by that amount. In our previous example, we were starting at 0 and increasing delta table by 1. And so 0, 1, 2, 3, etc. Now, if it's on auto, then this table of X values will automatically complete. Another alternative you can use is the ask option, in which case you can specify the X values in particular that you want, and it will only evaluate them once you put those values in. When you are done setting up the table setup screen, then go to second graph for the table menu to see the results. Now, if you've selected ask, then your screen is going to basically be blank initially. And so what you're going to need to do is you're going to need to enter a number into the X value, and then it will calculate that number in the equation that you have on your Y equals screen. So for this example, we went to second window to set up the table. We went down to change the independent variable from auto to ask. Again, just scroll over to ask and then hit enter. And then when you go to the table, then you'll have an option, your cursor will be here, and you can enter 3.14, and then it will evaluate the function at that point and display the results. Now, the other way that you can find a specific value for your function at a given value of X is to actually do this on the trace, on the graph itself. So from the second trace button, you will get the calc menu. And then the first option at the top is to find a value. So then press enter, and it will prompt you for the value of X at the bottom of the screen. And then you can press 3.14 and then enter, and it will go to that position on the graph, and then it will display the result on the screen. So it will look like this. So you'll go to the calculate menu. Again, that was second trace, which is the fourth button over from the left. It's next to the graph button. And then your screen will look like this, and it'll give you X equals at the bottom. You would enter 3.4, and then it will go it'll essentially reposition the cursor. It's right off the screen here at that X value, and it'll report the Y value that it calculates. If that point is on the screen, then you'll actually be able to see the position on the curve where that point is. But this is higher than 10, so it's actually like up here someplace off the graph. Now, another option that you can use is from the Y-Vars menu. So the Y-Vars menu is next to the clear button. It's on the third line down from the top, second over from the right next to the clear. And if you press Y-Vars, you will get some options. Scroll over to the submenu that says Y-Vars. And then the first option is for functions. Press enter. And then again, when you get to the function screen, you'll see a list of Y1, Y2, etc. Select the option from the list where your function is stored on your Y equals screen. So we put ours in Y1, so you would press enter. And then on the main screen, Y1 will appear, and afterwards, in parentheses, type the value of X that you want the function evaluated at. So in this case, we're trying to evaluate it at Y1, evaluated at 3.4. And when you press enter on this, this is like function notation, the result will appear over here. This is what the Y-Vars screen looks like. So when you first enter it, the vars, you would scroll over to Y-Vars, and then that's where you would see function and then Y1. And then the final thing that we're going to talk about, just as a reminder of things that we may have learned before, to find the solution to a system of two linear equations, we can put both of these equations into the Y1 screen. So Y1 would be 3x minus 4, and Y2 would be x plus 2. Now in the TI-84, you have options for colors that you can select. Older versions of the calculator will work basically the same way, but you won't have colors. And then when you hit graph, the lines will graph. Again, revisit the zoom section if you can't see both the lines or you can't see the intersection for how to adjust the window. And then to find the intersection where they cross, which is the solution to the system, find second trace again for that calc menu. But now instead of using the value option, which is the first one, scroll down to command 5, and then from there press enter. Now they're going to ask you for what your Y1 is and what your Y2 is. So just press enter at each of the prompts. And they're going to ask you, and maybe even for a guess, if you don't have more than one intersection. So if you're dealing with straight lines, you won't. You don't have to specify a guess. If you have any nonlinear equations and there is more than one potential intersection, you can enter a guess in order to get it close to one or the other of the intersections. If you don't enter a guess in that case, it'll find one of them, but it will keep going back to that same one over and over again, and it won't find a second one if there is another one on the screen. But for linear equations, just hit enter until it solves the problem for you. And then at the very bottom of the screen, it will specify the intersection, and the cursor will end up on the screen at that point of intersection. Now, as I said, if you are graphing nonlinear equations, you can't necessarily accept all the defaults all the time, and so you will need to pay a little bit more attention, and you may need to read the prompts and actually make a guess for that, either for the final guess, or if you have more than two equations on your screen, you may need to scroll through and make sure that you're getting the intersection for the two equations that you were trying to get the intersection for. So that it can be more complicated, but in most cases, it really is just accept all the defaults.